Welcome to a special live edition of the Bootloader. I'm Paul Cutler.
And hi, I'm Tod Kurt. To learn more about us or to subscribe to our podcast, visit thebootloader.net. And if you have a question or a comment, you can find us in the Adafruit Discord. We're kind of on there right now at adafru.it/discord. My handle is Todbot, and Paul's is PR Cutler.
So, as we were preparing for the show, I realized how far CircuitPython has come in the last year. While we're always looking forward to the next thing, whether it's Bluetooth on the S3 or the 2350 coming out, I'm reminded of the quote from Ferris Bueller's Day Off that says, "Life moves pretty fast. If you don't stop and look around once in a while, you could miss it." So we thought we'd take a look back at the CircuitPython project itself in the last year since last CircuitPython Day. So if we go back to the end of 2023, the first CircuitPython 9 alpha release was at the end of October, and 9.0 itself came out in March.
Yeah, and we have a huge debt of thanks to the MicroPython project, which is what CircuitPython came from, including Damien George and Jim Moussard and everyone who's contributed to MicroPython. CircuitPython is a kind of MicroPython, so we shouldn't forget that. They seem very different, but they actually have a lot of shared internals. And to that point, periodically the CircuitPython core team merges in the changes that have been happening to CircuitPython, and these are huge undertakings because they actually have diverged quite a bit. So props to the CircuitPython team for even trying to do this. For instance, the MicroPython 1.20 1.20 merge touched over 779 files, over 250 commits. And then they did three merges. They did the 1.19 MicroPython, 1.20, and 1.21. So I don't even understand how people can keep all of that in their head when they have to like do these crazy manipulations to update the software. So good job,
Right.
guys.
And Dan was mentioning how he's working on a couple more to come in the near future as well. So it's just amazing.
Yeah.
If we go back to last CircuitPython Day, CircuitPython 8.2.4 was released on August 22nd, right after we celebrated CircuitPython Day. If we take a look at 8.2.x to 9.0, there were 4,200 commits and 3,100 files changed. That's just a massive amount of work that the core devs in the community do every day. That's over 10 commits a day to CircuitPython. That's just crazy. If we look at some of the cool features that came out in CircuitPython 9, Connection Manager was released. That was a community member who put that together on how to manage sockets and networking. JPEG IO was released to support the Memento camera, and we got JPEG support. And just a couple weeks ago, we even got transparent ping support, PNG support. So we support all three major image formats now.
Yeah, being able to use PNGs now instead of BMPs, like in the sort of weird old school BMPs that were like back from Windows 3.1 days, uh, that'll be so much nicer because people can make PNG files much easier than they can make in the old BMP3 files. Another thing that it started right before the last CircuitPython day, really kind of got its foothold in this last year has been SynthIO, the ability to make a synthesizer, a music synthesizer in CircuitPython. And so I'm a big fan of that. My CircuitPython SynthIO tricks GitHub page is over a year old now, by like a month or two, and yeah, so it's I will show you later some SynthIO things, but suffice to say, it's amazing that we can just like make a synth in CircuitPython. Also, we have USB host now support. So now a single CircuitPython device can both be a USB peripheral to your computer, so it can serve like the CircuitPy drive, but it can also be a USB host to peripherals like keyboards or MIDI controllers, almost any other USB device. It kind of depends on which drivers the CircuitPython supports. But because CircuitPython uses tiny USB, or teeny USB, as Lamore calls it, uh, we kind of get a lot of that almost for free. Like there's a lot of driver functionality that's ready to go, and if it hasn't already been added, is going to be added soon as people need it. Another thing that I'm really excited by is parallel display bus, which so when you it's a way of controlling these tiny displays that are on these microcontrollers that's faster than normal SPI. Like if whenever we've controlled little displays, we're always at the bandwidth of the bus that we use to talk to the display. Like if we've got little I2C displays, you can't really update the whole screen 30 frames a second because there's just too much data to transmit over I2C. You can do a little bit more with SPI, but even that's not fast enough if you've got like a nice big, 240 square display. And so parallel display bus is 8 bits of data at a time, kind of like SPI, which is only 1 bit, but 8 times faster. And so there's some really great devices that are out there. There's some by LilyGo and some others that are like parallel. I think there might be a Adafruit board in the works maybe that has that. But we can now maybe start to use displays kind of the way we use them on computers, where we think about terms of things happen at a consistent frame rate, and we can just write the whole display.
That would be pretty cool.
And then one of the other things that's close to my heart is the MP3 decoder that's been built into CircuitPython, which does decoding in software rather than having a hardware chip that does the decoding, which is what happens on our computers and stuff. That decoder has gotten some improvements, especially on the ESP chips. So we can do higher bit rates now, and we can do URL streams, which means we can make a MP3 radio, like internet radio, with a CircuitPython device.
Yeah, I keep meaning to hook that up to Radio Free Fetty, which we talked about in the bootloader a couple months back, and I keep forgetting to do that. I have to make some time this weekend and see if I can get streaming MP3 to work.
Totally, yeah. So our little time here, our half an hour time, we want to kind of devote to how, like, the theme of like, what do you do when you want to use CircuitPython in a larger project? And like, what are some things? What are some tips? What are some things to watch out for? And what are some pitfalls? And like, how do you go from like a simple sensor demo or a simple like display twiddling to actually like a real project that you want to do? And so we're gonna base two big projects one that I worked on, one that Paul worked on, and we're going to discuss some of those things that we found that were useful to us. And to start it off, I'm going to talk about this little drum machine that I made in the last 2 weeks. And so it looks like this, and the whole point was that it is a drum machine the size of a deck of playing cards, and the real sort of like feature set that I wanted was that it has to have audio out because it's drum machine. It has to have MIDI in and out because you've got to like sync to other devices. You've got to maybe play, like when you play it, actually you can send MIDI out, and then it's got to have some sort of user interface. And because it has to be so small, I wanted it to be all cap touch, and I wanted then LEDs for every pad. And you can see I didn't quite get the LEDs on every pad because the space is a problem. But let me see if I can hook it up real quick. Let me switch my camera over here. And I lost my power supply. Hold on a sec.
That's what happens when we do it live.
Yeah. I thought I had this all set up, but I've gone out of order from my notes, so we'll have to. Which one is this? This is the drum machine. This is what it looks like when it's on. You can kind of see the LEDs are blinking, and then you can control it in various ways. And so these are backlit LEDs, reverse mount LEDs. They look like, oh, where'd it go? Well, here we go. The board looks like this. And the cool thing about it is that there's very few components on it. It's really just a PCB, and all of the UI is on the front. There's no electronics on the front, all the electronics on the back, and what electronics there are very minimal. So this is one of the design criteria, was that I wanted to make it very simple, very thin. I also wanted to make it battery powered, which is what this connector is there for. So the whole thing could be a nice little self-contained thing you can just slip into your pocket.
So it looks like that you're using the Raspberry Pi Pico on there. Is there a reason that you went with the Pico instead of like a Cutie Pie?
Well, so yeah, it's a Pico. So this is an evolution. I guess let me reveal everything underneath here now. This is an evolution of all of these projects. And so one of the first ones you might recall is this thing called Pico Touch, which is a Pico-based capacitive touch MIDI controller, USB MIDI controller. And it sort of looks like a ruler, and it's pretty nice. It's very thin. But it has electronics, like the electronics such as they are the resistors needed for the cap touch and the Pico itself. So maybe you could damage that. So let's think of an evolution of that. And so one of the next evolutions I had was this thing, which is the same idea, but it's a synthesizer in addition to a MIDI controller. And it's got reverse mount neopixels, which are commonly used in computer keyboard things. And let me turn on my little speaker so you can kind of hear it. Speaker, there we go. Hopefully you can hear that a little bit.
Yep, sounds good.
So yeah, so this is I've almost got these ready to actually send out to people. I made a run of 50 for a conference, and they worked out pretty well. And the nice thing about it is it's all self-contained. There's no electronics that you can damage on the surface. And other variations of that is this other Pico-based device. It's a little synthesizer as well that uses an I2S device and an I2S DAC to send to create the audio. And so all of these are using Cap Touch. There we go. This one's louder for reasons. Now, and of course, I forget his name, There's another great CircuitPython hacker who made a really nice sort of synthesizer improvement on this whole kind of idea. But the reason why the Pico is because it's got a lot of pins. And so all of these pads and all of these pads and whatever are read directly by the Pico. And so you can do a lot by just having a single board and then a bunch of just little modules kind of hanging off of it. This is an I2C displays. It's an I2S DAC. These are two pots, button, and then all the Cap Touch pads are read directly by the Pico. And so one of the evolutions of that was this tiny credit card sized. I was going to enter this into the Hackaday credit card challenge, but I ended up not. And so this was the first idea of let's take these reverse mount single color LEDs and do a Cap Touch. And this actually works pretty well as a little synthesizer. Sorry, as a little MIDI controller. This one does have MIDI out, has no audio out. And so you can see on the back there is no electronics. There's just the LEDs and the resistors for the Cap Touch. And so I'm a big fan of the Pico for this reason, because the Picos are what, $4, $5, and now you've got pretty much all you need to do a lot of stuff. You can do PWM audio out, you can do MIDI in and out. You don't really need much in terms of extra hardware. Now, the downside, though, is you start to run out of pins. Like in this case, I was driving each LED individually, which is how I'm able to do the nice PWM fade on this. But if I wanted to do the PWM on the LEDs and read all those Cap Touch, I was going to run out of pins. And that's why on the board that I designed 2 weeks ago, I guess it was 2 weeks ago now, I decided to use this fairly oddball touch chip to do all the Cap Touch reading, and this was kind of one of the problems I had. The other is that trying to fit all this functionality in something the size of a playing card is actually a little tough when only doing a 2-layer board, which is one of my other constraints. And so one of the things that that's really handy to use CircuitPython for is validate your circuit before you actually submit it to fab. Because one of the things I did with this one and with pretty much all the other ones is that I just opened up a serial REPL on a Pico and started creating the CircuitPython objects. I created a PWM object for each LED. I created a touchpad object for this one for each LED. I created the UART for MIDI out and the USB objects for USB in and out. And if CircuitPython lets you do it, then your circuit will probably work. And so my downfall for this one is that I didn't do that, because one of the problems that I quickly found, where's one that's actually wired up, is that I can't PWM most of the pins because of which pins I chose. So I can just do on-off. And that's really frustrating to me because I really want to have the pins be have this nice fade effect to indicate when you've touched it. So this is little drum machine functionality, and you can change patterns. You can change drum kits. So,
and that's all done with Synth.io.
This is actually doesn't have Synth.io. This is actually just plain WAV files directly off of the flash of the Pico.
Okay.
So everything else, pretty much everything else is Synth.io. Anytime it's this actual synthesizer. But this, I decided, hey, let's just do WAV files. And so the nice thing, this is sort of like what Guy DuPont was talking about in his video, is that, hey, because this just shows up as a USB drive, you can just drop WAV files in a directory, and this thing will load it up as a drum kit. And that's pretty handy, pretty powerful. You do run into the problem of like how much flash actually exists on this, and so like the bigger Raspberry Pi Pico compatibles that have 16 meg will be a better fit for that. But so this version of this board is kind of a failure, and it's kind of a failure for the reason of like not validating, using CircuitPython to validate all the functionality of the user interface and the various I/O devices that I wanted to have before I did it. Whereas I did exactly that validation on this board, which is it's just a cap touch thing. Hopefully it'll come up in a sec. No, does this battery might be dead. Oh well, I guess I can't show you this one. But this is a cap touch MIDI controller. There we go. And so little rotary sliders, linear sliders, buttons, and this is all just a Pico underneath. And so I was able to create all these objects in CircuitPython without actually making the board up, without making this PCB yet, to see that like yes, it all works. And so yeah, so that's my main takeaway is try things out before you make the board. Also, when code starts to get big, separating it out into separate files is really handy. Of having objects or just even just Python files that have the functions you want. And yeah.
Well, it's pretty neat.
So I think I'm going to do
Python to test all of that before building a PCB.
Exactly. Yeah, like doing the same sort of validation in Arduino is really hard because Arduino will kind of let you create two objects that need the same underlying hardware and will seem to work at first, but then it won't actually work. Where CircuitPython tries real hard to make it so you can allocate all the resources you need, and you don't have to worry about, well, which PIO state machine am I using on the RP2040, or which hardware timers am I using for the PWM? It's like it'll kind of figure all that out for you for the most part.
Very cool. Well, looking back at the last year, I wanted to pick my favorite project that I worked on. And this one I actually started soon after CircuitPython Day last year and kept iterating on it for about 6 months. It took me a little while. And when CircuitPython 9 came out, I ran into a gotcha and kind of had to start over in a way. But this is a project that I call Song Matrix. So it uses a Raspberry Pi.
Ooh.
Let's see if I can swap that out.
Yeah. Oh, yes.
I already have a Raspberry Pi in a 3D printed case sitting on my desk. It controls my stereo, which is in another room. And longtime listeners know I'm listening to music all the time. And whether it's on the radio or whether it's a record. But if it's a record, I don't have the art in front of me, so I don't know what the names of the songs are. So I'm a full album guy. I always listen to them front to back, but I don't know the names. So it turns out that there's a Python library called Shazam.io. And I can show that here. Someone actually reverse engineered Apple's Shazam API, built an asynchronous Python library that makes it dead simple to code. So if we take a look at the Python code that runs on the Raspberry Pi, we're going to import async.io. Well, it's still pretty small, isn't it? We're going to use Adafruit IO to send the message of what album or what song we're listening to. And then we're going to import Shazam IO. We're going to import a sound device's SD. And then we're going to use SciPy to actually write the file out. I'm using a $6 microphone that you can buy on Adafruit. Just plugs into the back of the Pi, does a great job. I've never had a problem recognizing a song yet. So looking at the code, you've got 3 lines just to create the recording. So it's going to record a 30-second sample, and you can go as low as 10 seconds if you want to and still get pretty good results. 30 seconds, you're going to get 99% of the time it's going to know what song that is playing in the background. So it records it, it writes it out to a file, and then you call Shazam here. And it recognizes the song, and then it comes back out and says, get the track title and get the artist. And that's all I need. And from there, I'm going to convert that into JSON, and I'm going to upload that payload right to Adafruit IO. Now, I wrap this in a try except because if there's silence or if it's a song that it doesn't recognize, you'll get a key error. And this way, I've got it set up that every 3 minutes to go take a 30-second sample. And if it gets a key error, it just waits another 3 minutes and then does it again. So that sends that up to Adafruit IO. So let's take a look at the actual code for the RGB matrix. I'm using an S3. So we've got the latest and greatest there. We're going to create the Wi-Fi, and I owe Anecdata in the Adafruit community some thanks. He helped me with some Wi-Fi challenges that I had. But you subscribe to your MQTT topic. You use your settings.toml to get your username and your key, and you set up requests like you normally would. And then you set up the matrix so it has a display. And then I wrap this in a try and except for a reason I'll get to in a second as well. But what I do is it just goes up to Adafruit IO and says, get me the very last song that was uploaded to IO. So it could be, if I haven't used it in a day or two, it'll show that last song. But the reason it's in a try and accept is if you don't have any data there, especially if you haven't used it in 30 days, if you're on a free account, you won't have any data. This way, it prints out a small error saying, hey, we're getting a 404 error on that. So here's where I print the error to the console if anyone ever actually uses my code. So what we do is we put this into a scrolling label, and we have the title of the song and the artist of the song. And we're going to repeat all of this code down in the MQTT when we get the message. So we get the message via MQTT. We get the title, the artist. We add some spaces so that it actually has something to scroll through. And then we come back and it listens to this. What's unique about this project is I made this using async IO. And there is a catch in CircuitPython 9 that you have to add a socket timeout. And Todd, I owe you a thanks for finding this. The reason I wanted to use async IO is that the MQTT query is blocking. So I don't want the scroll to stop when it goes out to download the latest song and song information. So using async IO, we can come down here with update the network. So this goes through and make sure that we're still connected to Wi-Fi. And if we're not, it'll reconnect. And then it does the MQTT client loop. So it's constantly checking MQTT at the same time that we're updating the user interface. So as it's scrolling, it's checking at the same time, and the scroll remains smooth. So that's great.
That's a great use of async IO.
Yes, it worked great once we figured out that socket timeout issue.
Yeah. Also, the try except, like anytime you do networking stuff, I think that's one of the other, like when you work on a larger project that has to be stable. Putting try except around kind of every network operation, because networking always fails. Like our computers make it look like it's always working, but no, it's always failing a little bit here and there all the time.
And I can tell when the network fails because it actually will stop scrolling for about 10 seconds as it reconnects for whatever.
Yeah.
So we've got just a couple minutes left, and you have something that you wanted to show that is hot off the presses that you just started working on this week.
Yeah. So in celebration of the I'm gonna switch my camera again. In celebration of the new RP2040, I actually got some of the RP2350 chips. I actually got a Pimeroni Tiny 2350 and a SparkFun Pro Micro 2350. So so I made a little demo using it. Oh wait, I forgot the most important part. So that's a little like Synth.io recreation, somewhat, of the THX sound called Deep Note. And then this is a little abusing the Stomach UT port that's on the Tiny 2350. I have it hooked up to my micro synth plug, and it's just playing WAV files. Sorry, it's playing high quality MP3 files. That's right. And so every button press, and so these are 320 kilobit, 44 kilohertz MP3s, and it just plays them. It's just really impressive that that we can do. Oops, we can do MP3s now. Lost the camera. There we go. Like I've stayed away from MP3s because the MP3s that you could play were like, you had to like reduce the bit rate and reduce the quality of them, and it just wasn't very good.
But that extra processing power in the floating point unit seemed to make all the difference on the 2350 for MP3s.
Yeah, I'm not even sure they've tuned the MP3 decoder for the RP2 board port to use the FPU yet, the floating point stuff. But yeah, it's Go RP2350. I can't wait to play with it more.
That's awesome. Well, that's our show. If you want to learn more about our podcast, visit thebootloader.net. And if you have any questions or comments, feel free to leave them in the Discord. Todd and I will be hanging out there as well. Thanks for watching. And Trevor and Brent are up next.